So when we talk about test, right, I mean, the test is not to scare anybody, okay? I'm not trying to assess any one of you. What I'm trying to assess as part of test is, have I explained the concepts well enough to you guys? What are the things that you guys are still struggling with conceptually, right? Even if I have taught it or not taught it before, right? So the tests are meant for making sure that I'm able to at least reach all of you to understand what are the areas where we have some opportunity for learning or practicing things, okay? So my tests are a little different. Nobody's going to get a score. It's only me who gets rated as part of the score to know where I've done a good job as a teacher, where I have not. So nobody should freak out, nobody should worry, nobody should get stressed out for the test that is happening tomorrow. You all will come with a very cool head. See what you know and what you remember and what you are not comfortable with. Yes, Vishal?
There's a test tomorrow?
Yeah. And,
What,
I'm sorry?
like what time?
3:30 to 5 Central. So instead of 3, we'll start at 3:30 and it will be a combined test for all the kids, all the grades, all the levels. So I'll be sending, so the kids who are not in DFW, right, who cannot come to the class, they'll be doing it online. The only condition is you'll have to keep your video on, okay? I mean, just to get a feel of a real life test, okay? So
Is it online or like?
So the kids who are in DFW area or Dallas area, they are requested to come in person. Kids who are not in DFW, they will do it online. So you will just log in like you log in for the meeting, and I will send out the just before the test I will send out the question paper, and then you will work on it. Okay. So we will do that in next 1.5 hours. I mean, ideally it will be 1 hour test. Initial 15 minutes for settling down for everybody to kind of get the question paper, settle down, and then we will see if we are able to solve all the problems that we have for the test in 1 hour's time. Okay? Yes, Shreyan.
Sir, I just joined the call. So when is the test gonna be?
Tomorrow 3:30 p.m.
Okay, sir.
and I would assume to see you in the class tomorrow. I mean, I will not in the classroom. I will take you guys all upstairs where temperature is little better, and everybody will sit down and do the test. Okay?
Okay, sir. I'll try to come.
Okay, wonderful. So all the kids who are here in Dallas DFW area, they will be doing it in person. They are supposed to do it in person. If somebody cannot make it, they'll do it online. But it'll be better if you can do it in person. Everybody else who is remote will do it like we do the classes. Alright? Okay. So let's get started. And again, for you guys, right, it'll be a full-blown sample test of SAT, okay? And some of the concepts that we have covered, some of the concepts that we have not covered, don't even worry about it. When you guys do the test, send me your answer sheet. I will go through it, and that will give me a good sense of what are the areas for most of you where we have to kind of redo it or brush it up again. So that's the whole premise of how we do test. Okay. All right. So let's do a quick roll call and then we'll get started. So I see Davik is here, Jenna is here, Chris, then Neil, Sarah, Nirunya, Praneeth, Purvi, Riya, Ritika, Saranya, Shriyan, Vishal, and Viswa. Alright. So nobody should, I mean, like for kids like Jenna and Viswa, right? I mean, you have just attended few classes, and it will be unfair to say, okay, I mean, it will be unfair to compare the new kids with somebody who has spent some time with me. So again, I'm not going to rate anybody, nobody's going to get a score. It is only for me to get an insight into who knows what and where I have to put more focus, okay? So if your parents say how much you scored, say talk to my teacher, okay? Alright. So let's start then. What are we going to cover today? That's a question, and that too before the test. So the unit that we were doing, that is unit 11, where we are talking about advanced math or advanced algebra, and we started with the linear equations, system of equations, and we have a new child in the class, Inesh.
Hello.
And this is your first class. So Inesh, this is a class for SAT preparation, all the kids who are in high school. So this is where the only thing that you need to be aware of is when I'm teaching something, I'll try teaching the concept part of it, and my request to you would be, don't worry about taking notes, because whatever I'm doing is getting recorded. It's only me getting recorded and the board getting recorded, okay? So you will have video of the class after the class is done. So whatever we covered today, if you think you've missed something or you don't remember, you always have the video to refer to it, and that relieves you from the stress of noting down everything or making sure that you're not missing anything, okay? And feel free to ask questions, feel free to argue with me if you have a different point of view also, okay? So it's not a monologue where I will just say something and you have to find that something written in stone. Alright, so like I was saying, we are in unit 11 of SAT prep, which is around advanced math, advanced version of algebra. And again, whoever has joined in between, be it Jenna, be it Vishwa, be it Inesh, you guys don't have to worry about it, because after unit 11 we have unit 12 and 13, and then we'll again repeat the cycle. So math is all about practice. Praneeth, who has been with me for longest, he has done 2 rounds of practice already, and he will do the 3rd round, 4th round till he gets tired of me and SAT both. Alright? So let's get started. So in this unit we are going to talk about again system of linear equations in the more advanced form, where we'll talk about how do we solve system of linear equations, and also how do we deal with some of the word problems relating to system of linear equations. Is that okay? Jenna, Inesh, Davik, Praneeth, everybody okay? Okay. And I'm just calling out some names. That doesn't mean I'm ignoring anybody. Your name can be called out anytime, because it's my job to make sure that everybody is awake and with me 100%. Ritika, okay, beta?
Yeah.
Okay. So now, in this topic, before we start doing some problems, right? One thing for sure is, I'm going with the assumption that you are all comfortable with the basic concepts around how do you solve the system of linear equation. There are 2 methods essentially. One is called method of substitution and one is called method of elimination. And we talked about that in the previous class. Most of you would remember it. If you don't remember it, don't even worry about it. When we solve the problems, it becomes part of our routine actually. So let's pick up one problem and then see how easy or difficult it is looking. And again, since this is part of advanced algebra, it will give you the feeling that this is difficult, but you don't have to feel it that way. Let's look at one problem as a problem. Okay, Vishwa, are you with me so far? I'm just putting the question first, then we'll talk about it. So these are 2 equations given, okay? 1.5a minus 4.5b equal to 3 times a plus b, and second equation is 5.5b equal to 5b minus a plus 2.5b, and let's read the rest of the question. It says if a and b is the solution to the system of equation, meaning if a comma b is the solution to the equation of solution to the system of equations, then what is the value of b minus a? This is a very standard problem. If you look at it, this is one equation, this is another equation. The variables here we have are a and b. Here also a and b. And says if A comma B is the solution to the system of equation, that is what we have learned so far, that if you have, this is a linear equation because maximum power to the variable is 1. Here also it's a linear equation, meaning both of these, if you try drawing on a coordinate plane, we'll draw two straight lines, and wherever they meet, that point, the x and y coordinate of that point satisfies this line and this line both, meaning you have to solve these two equations and find out the value of A and B which satisfies this condition and this condition both, same as x and y scenario. So that's what it's saying. These are two equations, and A and B is the point that gives you the solution from the system of equations. Then find out the value of B minus A. So essentially you have these two equations. Instead of x and y, you have A and B as variables. That's just a different name, right? Today you are learning math from me. My name is Biraj. Tomorrow you should find that, okay, I'm not a very good teacher. You will find a better teacher, a different teacher, and his name will be, let's say, Ramesh. So Biraj becomes Ramesh for you. Math remains math for you, but your teacher's name changes. Likewise, here is the variable A and B. We are used to solve it for x and y. We will say, okay, fine. Instead of x and y, we have A and B. And if you're not comfortable with A and B, you will say, okay, I'll replace A with x, B with y, and then I'll solve. Any which way is okay. So let's not deliberate on that. Idea is we have these two equations, and this is the solution, meaning we have to solve it for x and y, and then find out the value of B minus A. So I'll read the question one last time for you guys, and I want you guys to break your head with this, and then we'll come back to what your teacher has to say to unify all the solutions. So the question is again 1.5a minus 4.5b equal to 3 times a plus b. This is one equation. Second equation given is 5.5b equals 5 times b minus a plus 2.5b. If a comma b is the solution to the system of equations, then what is the value of b minus a? So now I'll give you guys 5 to 6 minutes to try solving it. Before you try solving it, come up with your approach. So, Inesh, this is your first class. I'm sorry, Praneeth, Derek, everybody. So, the method that I recommend or prescribe to all my kids, you all are my kids, okay? That's how I treat you all. The method that I prescribe is called RAN. Who wins the race? Who ran the best. R stands for reading, A stands for analysis, and then N is the short form of Nike, which says just do it. Meaning if you have a problem to solve, read it enough, analyze and come up with your plan, and then you do it. That's the whole idea. Don't look at a problem, jump onto solving it. That's my recommendation. Yes, Vishwa.
Oh, do we solve on both or just one?
How would you solve one?
No, do we solve on both?
So here's the thing. If I have an equation like this, x minus 2 equal to 15, one equation, one variable, you can solve it for x. If I say x plus y equal to 17, you have one equation, two variables, you cannot solve it. So the rule of thumb is, if you have to solve for two variables, you need minimum of two equations. So now you have two equations with variable a and b. Use those two equations to solve for the value of a and b. And again, this might be new to some of you. I understand. So that's why I was talking about the two methods of elimination and method of substitution. We'll come to that. I'm just wanting to give you guys 5 minutes to think through it, and then we'll come to it. Okay? Vishwa, did I answer your question, beta?
Yes, sir.
Okay. Yes, Vishal.
In the first equation, it says 1.5a minus, what is it?
4.5b.
Oh, 4.5b.
Uh-huh.
Okay.
Ria, Neil, Sarah, Sriyan, is everybody giving it a shot? Okay. Ritika, Nirunya, are you guys trying as well? Okay. Now I'm just calling out names, okay? I'm not trying to put anybody on the spot. I'm just trying to make sure that all my kids are with me, okay? Yes, Vishal. Inesh, is that problem clear to you, beta? Okay. So again, I mean, this problem might take 5 minutes, 7 minutes, 8 minutes to solve, but I will, just in the interest of time, I'll probably stop you guys after 2-3 minutes and then see who can give me some approach around it. Okay. Purvi, are you giving me to try with her?
Yes, sir.
Okay. I am not doubting anybody, I'm just reminding. Okay. Chris, Jenna, everybody? Okay. Hey Rehan.
Yes, sir.
So Rehan, just while everybody is working on a problem, tomorrow we have a test. Okay.
Okay, sir.
And test, all the kids who are remote, they will do it online. The kids who are in Dallas area, they will come and meet me in person and do the test like, you know, real life test. Even for the kids who are online, make sure that you come dressed up as in ready enough to keep your video on, okay? I don't force you guys to keep a video on, but when we are doing test, I will request you all to keep your video on. So it gives you that actual ability to simulate a test-like scenario. So right now we're trying to solve the system of equation, okay? The equation says 1.5a minus 4.5b equal to 3 times a plus b. And second equation is 5.5b equals 5 times b minus a plus 2.5b. If a comma b gives the solution to the system of equation, find out the value of b minus a. That's the question that we are trying to solve. I have given probably 3 minutes already. I'll give 2 more minutes and then see who has the solution for it or who wants to give me at least an approach for solving it. Rehan, you got the question, beta? All right. David, what's going on? Okay, let's yes, beta?
Sorry, I just came back. My mom was like, I have a guest coming over, so I had to help my mom with something.
Okay, no worries. So we are trying to solve this equation, okay? This system of equation. I hope you guys can see it, okay? Or let me change a bit. The lighting is always a distraction. All right. So, okay, let's pause wherever we are. Now, who can give me that story? How are you approaching this problem? Yes, Praneeth.
So first, I take the second equation and isolate b to get a value of b. Then plug that into the first equation.
Okay.
And then get the value of a to get and then plug it into the second equation, get the value of b.
Okay. So that is the method of substitution, correct? Okay. Any other thoughts? Ritika, Riya, Vishal, Sarah, Neil, anybody? Jenna, Irunya, anybody?
Well, I was gonna say I was solving it the same way as substitution, so I don't have anything else.
Okay. Okay. Purvi?
So I used elimination. So I grouped the variables a, b, and then the second equation a, b, and then I put it as equal to 0. And then I found a common thing that's gonna be multiplied, so you get the number. I don't know how to explain it. So I did that, and then so I found the like common multiple and I multiplied it with all the values of the second equation. And so I crossed the a variable, so I got 1.8 for my second. I don't know if it's right. I got 1.8, and I multiplied it with my second equation, and then so both of them are like 4.5a, and the other one is negative 4.5a. So I canceled them out, and I was left with b, and I did all the math, and I got negative 0.27, and I just plugged in the b for the a, and I did.
Okay. So I'm very happy. No worries, Ria. Thanks, Purvi. So see, what I'm happy about right now is not everybody in the class is using one method. Praneeth and and Ritika used method of substitution, and Purvi used the method of elimination. Let me add some more color to it. So coming back to Vishwa, your point, right? See, you were mentioning that how do we go about solving it, and some of it might be new to us, some of you, right? So ultimately we have these two equations. You have to solve it for a and b, find the value of a and b. Once you find that, then you have to find out b minus a or a minus b, and that you can find out. It's okay. So first objective is to solve it. Now you guys are very young, full of energy. I'm getting old. That means I'm getting little lazy. What it means is, it has nothing to do with age. What I'm saying is, solving it, there is always a very straightforward orthodox method for solving it, and we know method of substitution, method of elimination, we can use them. Here, there's one more thing I want to do. See, my problem is 1.58, 4.5b, then a natural number. Again, it gets me a little uncomfortable. Now I see a and b on both the sides. Can I look at simplifying it? Let me look at this equation in a more simplified way, let's say. I'm starting with this one. 1.5a minus 4.5b. What I will do is, I will try bringing all the a's on one side, all b's on one side, and then we'll see what happens. So this part I've written as is, and then this becomes 3a plus 3b. Okay. Now, if I get all the a's on one side, meaning move this guy this side, and all the b's on one side, and move this guy to that side. So I have 1.5a. This side becomes minus 3a equals, this goes to that side, becomes 4.5b, minus becomes plus 3b. Okay, now we have a little more friendly looking equation, at least one of them. It becomes minus 1.5a minus 3a becomes minus 1.5a. Now this is 4.5b plus 3b, that is 7b. Okay, so from this what did we find? Okay, so if I look at 1a is equal to what? I will move this to the other side. So 7 over 1.5b, this is what we'll get. So 7 over 1.5, okay, so let's simplify this. So let's take the decimal out. A equals 7, this becomes 7 into 10 over 15 minus b. I will keep the minus sign in the bracket for the sake of simplicity. So this becomes 2, this is 3. 5 2s are 10, 5 3s are 15. 14 over 3. So now what we find is A equals minus 14 over 3b. So we got a value for A. The same A value of A we can substitute in any other equation. So I was trying to find out a way to simplify it. Okay. First equation gave me this relationship. I can put that here and solve it. Or what I can do is I will keep it here. See, 1.5a. Here I got minus 1.5a equal to 7b. And then let's look at this equation, okay? So when you look at this equation, from this equation we got the value of A equal to this, okay? Now let's look at the second equation. Meaning when I'm bringing this equation down and trying to simplify this, what do I get from here? Okay, 5.5b, again same thing we'll do. Get all the b's on one side, 5b minus 5a, I'm breaking this open, plus 2.5b. So 5.5b, this comes here becomes minus 2.5b, and this comes here, it also becomes minus 5b, equals minus 5a. Okay, so here we get 5.5. Am I missing something? No. Yep. Vishwa.
I can't completely see the board. It's like kind of blurry.
It's blurry, or is it because I'm using a lighter pen?
I can see the first two equations, but the bottom is kind of like.
Okay, because I was using a lighter marker.
Oh, okay.
Thanks for pointing it out. Okay. I'm just writing the equation in a simpler way. Minus 2.5b minus this comes here minus 5b equals minus 5a. So from this 5.5 minus 2.5 becomes 3, minus 5 becomes minus 2b equals minus 5a. Okay? So this equation gives you this relationship. This equation gives you, okay, so from here these two will kill each other. A equals 2 by 5b. So 2 by 5b, here I'll put this value 2 by 5b equals minus, am I doing it right? Am I missing something in the equation? Let me look at the question real quick. Oh, okay, that's why. This was 2.58, I messed it up. That's why I was thinking why I'm getting a different value here. So this becomes minus 2.58. Okay? So basically what I'm saying is when you have this equation now, A equal to 2 by 5b. Now here you have value for this. You substitute this minus 14 over 3b equals 2 by 5b. So you will say, get everything on one side, 2 by 5b plus, this goes to other side, that becomes plus 14 over 3b equals 0. So here, I should take, what is happening? Okay. I think I am messing up something in between. Okay. Let me not complicate this. Let's keep it as simple as it is. Okay. We have these two equations. From this equation, find out the value of A. We got minus 14 over 3b. A equals this value. And this is the second equation. What you will do is, you will put 5.5b equals 5 into b minus a. So minus into minus, 14 over 3b plus 2.5 okay. I am actually thinking if there is a smarter way of doing it. Okay, got it. Whatever I did, forget about it. We have two equations, okay? We have to solve it for A and B. And now you guys will see what I'm trying to do, okay? We have to solve it for A and B, and then find out the value of B minus A. Okay? So from this one we found, okay, let's look at this equation. I'll show you what the trick is here. 1.5A minus 4.5B equals 3A plus 3B. Okay? So let's solve it. Get everything, all the A on one side, B on one side. So 1.5A minus 3A equals 3B, and this goes to that side because plus 4.5B. So you got this as minus 1.5A equals 3B plus 4.5B, 7.5B. Okay? So A equals 7.5 by 1.5 or 75 by 15B. So minus this. So this becomes A equals 15, 5 to 7, 15. Okay, this is 15 over 3. Okay, sorry. This becomes 1.5 into 5. So this is 5B, minus 5B. A equals minus 5B. That's what you got. Okay? So A equals minus 5B. This is a value here. Now you come to this equation, and what you have to do is A equals minus 5B. So if you put it in this equation, what will happen is 5.5B, you bring it here, minus 2.5A equals 5 times B minus A. What you have to find is value of B minus A. Let's find out this value and then we'll divide that by 5. That will be our value. Okay? So this becomes 5.5B minus 2.5A. Again, every A is equal to minus 5B. So minus 2.5 into A is minus 5B, equal to 5 times B minus A. So it becomes 5.5B minus 2.5 into this. So this becomes plus 2.5 into 5 becomes 12.5 B equal to 5 times B minus A. So here 5.5B plus 12.5B, that is 18B equals 5 times B minus A. So B minus A will be equal to 18 by 5B. So here with this problem again, you have the method. So what was the value that you got, Praneet or Purvi? Exact. Did you get an exact value, or you got that in relationship? I mean, as a relationship between A and B.
I didn't finish, so.
Okay. Purvi, what was your answer, beta?
I got decimals. For B minus A, I got 0.183.
But my worry here is, how would you get that? You don't have any constant here,
Yeah.
right? That's what even I was trying to get to a solution. Then I realized that in this whole problem, okay. So let me kind of help everybody get a very simpler view here, okay. So if I have, let's say, x plus 5 equal to 50 as an equation, I can find out x equals 15 minus 5. I'll get an absolute value. Yeah. If I have my equation as x plus y equal to 2y, the answer that I'll get will be in relationship between x and y, in terms of x or y only. If you look at this, I have no constant here. Every constant that I have is only as a coefficient. So it only tells me the relationship between the two variables. It doesn't give me any absolute value. Yeah? So, okay, now let's do a quick recap. This was a new problem for me also, okay? Because when I was solving this one, I was trying to get that absolute value and I was not able to find out, and that is where my struggle was. but then the basic underlying principle doesn't change for us. Okay? So here, if you have to solve an equation like this, obviously your base approach would be method of substitution or method of elimination. You find out the value of one variable. Here everything is a variable. Constants are only a coefficient. There is no absolute value. Say, okay, this plus this equal to 70, or this plus 70 plus 5 equal to something. Nothing like that. There is no constant, no individual constant that you have here. You have only in the relationship between A and B. So from this one you will find the value of A with regard to B. When you put that value here, you will only get a relationship between the two variables, meaning in the form of a ratio. What I was trying to do was, when I saw this one, okay, we were ultimately asked to find out value of B minus A, and we found a term B minus A. So from here, what I did was I found the value of A and put that value here. So everything is B now. So this is something B comes here is equal to 5 times B minus A. We did not put the value of A here. We just substituted this value of A in terms of B, did the calculation and divided that by 5. That is what gives us B minus A. That would be a faster approach. I was trying to solve it in the most orthodox way, but it took a little longer. But then I realized that, okay, when you have a clue here in the problem, you will not do that the normal way. You will rather do it with some way of saving time. Okay? Does that make sense? Inesh, I know this might have sounded like a ride. Was that okay to understand or cryptic? Okay, Vishwa. So again, one thing before we pick up the next problem, okay? One thing that we are trying to do, okay, is that our most convenient or the easiest situation to look for solving for any variable is where we have something like one equation with one variable only. This is a variable, these are constants. If we get to a point like this, then we can find out the value of the variable. So whenever we are dealing with situation like this, we have two equations with two variables. What we have to do is find out the value of one of the variable. Here, when you from this equation, let's say if you try finding out the value of y, what you're doing is you're moving x to that side. So y equals 28 minus x. So when you put that value here, you will see that, okay, you have x before, and again from this equation you got 28 minus x. So you literally got rid of the second variable, and this becomes 2x minus y. This y is nothing but, which is coming from here, is 28 minus x equal to 5. Now look at the situation. This equation, which had two variables, which was making our life complicated, transformed into an equation with one variable. Now from this, if you have to find out the value of x, it's easy, right? 2x minus 2 times 28 is 56. Minus into minus becomes plus x equal to 5. So you have 2x plus x, 3x, and this 58 goes to the other side, equals 5 plus 58. Oh, 3x equals 63. So x equals 63 over 3. So ultimately, this is the method of substitution, where you substituted the value of y from the previous equation to this equation and you solved it. Similarly, there is a second method that is called method of elimination. Again, I'm just helping some of you recall what we have learned in the class where you were not there. So if I have these two equations, with the equations we have the freedom and luxury of multiplying all the terms by one number or dividing all the terms by one number. Doesn't change the overall behavior of the equation. Multiply, divide. Let's say if I like number 4, I'll multiply all the terms with number 4 and then my equation remains the same. If I have any need to divide, if I divide all the numbers by 1 by 6, if I divide all the numbers by 6, Still the equation remains the same, untouched. So that being said, or if you have a couple of equations, if you add them or subtract one equation from other equation, then also the overall behavior of the equation, the purpose of the equation doesn't change. And we will talk about that when we talk about one solution, multiple solution, or no solution scenario. But for now, that's the underlying principle. Now if I have equation like this, I have two equations. In the first scenario, we took the value of y from here, put it here, and we were able to solve it. Now if you look at these two, oh, I have a plus y, I have minus y. What if I add these two equations? Just add them. So x plus 2x become 3x. Oh, here I have plus y, I have minus y. They nullify each other. Plus 0 equals 28 plus 5, 33. Yeah. So from this we can straight away find out the value of this. So this here what happened was we manipulated the equations in such a way that we could knock off one of the variable. See, with the method of substitution or with the method of elimination, both ways we have got to a point where we have a resulting equation which has only one variable. That is our desired state. Whenever you are solving any linear equation, quadratic equation, whatever, your ultimate goal is to come to an equation with one variable only. Once you come to that, then everything falls in place. Once you find the value of x here, you put here or here, you'll get the corresponding value of y. Okay? So this was just to do a recap of these two methods. Let's pick up one more problem. I know I'm going a little slow, but it's okay. I have an equation, okay? I have pair of equation. It says x equals 1 by 3 y plus 4. Second equation is 4x minus 3y equal to 3 times a minus x minus 2x. These are two equations given. It says in the system of equation a is a constant. For what value of a does the system of linear equation have infinitely many solutions? For what value of a? These two are system of equations where a is a constant. If you look at the first equation, it is x equals 1 by 3 y plus 4. And this is saying 4x minus 3y equal to 3 times a minus x minus 2x. Says for this system of equation, here a is a constant. We don't know whether a is 1 or 21, 99, 1 over 6 or minus 8. We don't know. It says find out the value of a for which these two system of equations have infinitely many solutions. Did everybody get the question?
Can you repeat it like one more time?
This is one equation, x equals 1 over 3 y plus 4. This is second equation, 4x minus 3y equal to 3 times a minus x minus 2x, where a is a constant. It says find out the value of a for which these two system of equations have infinitely many solutions.
Okay, thank you.
Now, before anybody tries attempting the problem, what are the circumstances under which you will have infinitely many solutions? Anybody? Yes, Shreyar.
For linear equations, if they have infinitely many solutions, they would have the same y-intercept and slope.
Same y-intercept and the slope. Exactly. So again, for any other thoughts? I will even simplify this. I will say that for having two equations to give you infinitely many solutions, they have to be the same equation. I mean, they should be simplified to form the same equation. Now let's look at the intuitive part of it. If I have coordinate plane, I have two equations, linear equations. both are drawing straight lines, obviously, meeting at one point. How many solutions we have? Only one solution. This is where both the lines are meeting, and that is the one solution that we are talking about. Let's say I have a coordinate plane. I have two equations. When I draw them in a coordinate plane, they draw a line like this. How many solutions we are talking about? Zero solution. Because they are not meeting anywhere, they are not interacting anywhere, they are not intersecting anywhere. What it means, if any point on a line is represents that this is abiding by the contract of the equation. Any point on this line abides by the contract of this equation. If these two equations, if these two equations are not cutting anywhere, that means there is not even a single point which abides by the contract of both the equations. Okay? Meaning there is no solution here. They are not meeting, there is no solution. There is no one common value of x and y which satisfies this line and this line both. Yeah? When we talk about infinitely many solutions, what we are talking about is two equations drawing the same line. They are just overlaying each other. That is a circumstance where you will have infinitely many solutions. Does that make sense to everybody? Jinnah, are you with me, beta? Yeah?
Yes.
Yeah. So, see, if I'm saying infinitely many solution, meaning pick up a point. Oh, this point satisfies this equation and satisfies this equation. One solution. This point satisfies this equation and this equation. Wonderful. Second solution, third solution, fourth solution, fifth solution. Okay. You can just go on. And anybody in the class who believes that you can count how many points we have between this small portion of the line, that would be difficult to believe. Points you cannot count, right? You are already seeing uncountable number of points which is satisfying both the equation. So basically when you are talking about infinitely many solutions, you are essentially talking about two equations drawing the same line. Now when will it do so? And now going back to the same concept that we were talking about. X plus 2y equal to 5. This is one equation. If I multiply everything by 2, what did I say? This doesn't change the behavior of the equation. What I meant was, this becomes 2x plus 4y equal to 10. This line and this line are essentially the same. When you try drawing it on a graph paper, you will see that both are drawing the same line. That is exactly what I meant by having the freedom or luxury of multiplying any equation by any number or dividing any equation with any number doesn't change the behavior. When you put that in the, create the table of x and y and put that here and then plot in a graph paper, you will see that both draw the same line. Okay? I'm not doing that just in the interest of time. So going back to this theory of understanding, what it means is this equation and this equation will be multiple of each other. Let's simplify them. Let's see. Let's get all the fractions out. It becomes 3x equals y plus 4. This is my one equation. Now look at this equation. This is my first equation in a simplified way. Second equation is 4x minus 3y equal to 3a minus x minus 2x. Let's keep x and y separate and see what happens. Like we have 3x here, right? Let's get all the x this side. So this becomes 4x minus 3y equal to 3 into a minus 3x minus 2x. How many x we are talking about? We are talking about minus 3 minus 2, 5x. All comes here. So 4x minus 3 minus 2 minus 5x. This comes this side, becomes 5 plus 5x. And then take the y to that side. Equals 3y. Minus 3y becomes plus 3y. Plus 3a. Now if you look at this equation became or transformed into 4 plus 5x is 9x. equals 3y plus 3a. Now we are getting some clue here. For this equation, see here it's a bigger number, right? 9x, 3y, 3. Okay, let's do one thing. We have the luxury of dividing or multiplying by a number, right? Any common number. We see 3 common here. So let's divide this by 1 by 3. What it became? 9x by 3 becomes 3x equal to y plus 3 by 3 becomes a. 1a. See, now you compare this. These two are same equations. So a equal to 4 will convert, a equal to 4 will convert these two equations to the same equation and hence give us infinite number of solutions. Did that make sense? Purvi, Jenna, Inesh, Neil, Sarah, everybody. So again, now it gives me an opportunity to brag about what I keep bothering or torturing you guys with, right? I always say that use this. And you would have seen when I saw these two equations, which was saying, okay, find out the value of A, where these two equations give you infinite number of solutions. Now, under what circumstance it will give me infinite number of solutions? So the kids from the next class, from level 1 who have joined early, I think it is Lakshmi. So 8 more minutes, okay?
Okay.
So here, as soon as we saw these two equations, and for them to give us infinite number, so then we read the question and then we are thinking, okay, for us to get infinite number of solution, meaning one equation has to be a multiple of other. And this was looking cryptic, this was looking cryptic, we simplified it. And as soon as we simplified, this became 3x equal to y plus 4, the first one, and second one became 9x equal to 3y plus 3a. And as soon as we converted to simplified form, it was looking much more easier. Because we know that, okay, if I have any equation, I can divide or multiply by any common number, all the terms. And then you see, okay, this also can be treated as 3x equals y plus a. So this is the same equation. For them to kind of have infinite number of solutions, these two have to match. And that becomes the same line. Yeah? Is everybody with me? Did I make decent sense or I was just blabbering? Ritika, Neil, Sarah, Nirunya, Riya and Saranya has been very quiet today. Are you guys with me, beta? Did I make enough sense or I was just blabbering? Vishal, convinced? Okay. Now, we have 6 more minutes. So the kids from level 1 who are joining now, you guys will get haunted by these difficult looking problems. Don't worry about it. Your class is starting in 6 minutes. For next 5-6 minutes, just enjoy the toughness of the problem. Okay? It is not tough, just that you guys are way too young. Now let's look at this problem. 19 minus 38y equals 76x. 24x equal to minus 6 into 2y minus 1. Consider a system of equation. How many solutions x and y does this system have? Shh, keep quiet. Just find a place for yourself. There's a class going on. So there are 2 equations we have. It says find out how many solutions this system of equation have. There are only 3 scenarios that, again, we will not have enough time to solve it. But when you look at this problem, it says, find out how many solutions the system of equation will have. First thing you have to do is recollect your thoughts. If I have these 2 lines intersecting at one point, I have one solution. If these 2 equations are being parallel, no solution. If these 2 lines are coinciding with each other, infinite number of solutions. And how you can determine that? This is where you'll have to cut again. Always the beauty of the problem lies in how you simplify them. Here you have in this format, here you have in some other form. Get everything to one side and then we will compare them. Stay calm, no dancing, singing. I am teaching here yoga. Do you think I am cracking joke here right now? So keep quiet and stay stable. Be respectful to the fact that there is a class going on. You are not here to disturb everybody. Okay? Including me. Yeah. So when you have 2 equations, right? First thing you have to do is simplify them. It looks little. So here, look at this equation. I'm not sure who all know the table of 19. In this equation, this is 19, 19 to the 38, 19 4 to 76. I can simplify this by dividing this whole equation by 19. Look at this becomes 1 minus 2y equal to 4x. This is the simplest form. Now look at this equation. What is this? 24x equal to minus 6 into 2y. So minus 12y minus into minus plus 6. Oh, here also you see the same thing. Multiple of 6. So it becomes 4. You divide everything by 6, it becomes 4x equal to minus 2y plus 1. Now look at this. 4x, 1 minus 2y. 1 minus 2y equal to 4x. 4x equal to 1 minus 2y. Aren't these 2 equations the same? How many solutions we are talking about? David? If I have 2 same equations, how many solutions we are talking about? Sriyan, Vishwa, anybody? Inesh, Rehan? If I have 2 same equations, how many solutions we are talking about? Infinite number of solutions, because they are same equation. No matter how many times we wake up and draw this line, we keep drawing the same line. Infinite number of solutions. That brings us to the end of the class. I have put some more problems which we could not solve, but I will let you guys try some of those and come back to me if any of them are found difficult for solving it. Okay?
Yes, sir.
Alright, with that being said, I'll let you guys go. Best of luck for the test tomorrow, not to you but to me. Alright?